A telescope in Chile has done something extraordinary. It captured a comet traveling from beyond our solar system, a true visitor from the vast, dark reaches of interstellar space. This object, known as 3I Atlas, wasn't just any comet. It was a cosmic enigma, behaving in ways that left even the most seasoned astronomers stunned. What they witnessed has the potential to rewrite what we know about the solar system, about comets, and maybe even about life itself. The Vera C. Rubin Observatory, scanning the skies for fast-moving objects, was the first to flag it. At first, it seemed like a standard discovery, a faint object, a cometary glow, a streak moving through the deep sky. But as more telescopes turned their eyes toward it, things became stranger. Its journey through space was eerily silent, and yet, it seemed to carry a message that, for reasons we don't yet fully understand, it could not deliver intact. 3I Atlas shattered. Not gradually, not with a slow fading, but violently. It fragmented into countless pieces, scattering debris across the solar system like breadcrumbs left behind by a cosmic traveler. The sight was haunting. Images from the Hubble Space Telescope were almost otherworldly. Distinct chunks drifted apart, each continuing along the same trajectory, as though the comet had planned a final, spectacular exit. But the real question remains: why did it break apart at all? Comets are fragile by nature, yes, but interstellar comets like Atlas are thought to be hardened by eons of survival in deep space. They endure near absolute zero temperatures, constant bombardment by cosmic rays, and the brutal gravitational tides of countless stars. For 3I Atlas to fall apart so completely suggests something extraordinary, something beyond the usual fragility of cometary bodies. Was it a violent internal event, a structural flaw, or something else entirely? Some scientists whisper a bolder possibility: that maybe it wasn't a comet in the traditional sense at all. Could it have been a probe? An alien device? A self-destructing interstellar messenger? These questions sound like the stuff of science fiction, and yet, given what we've seen, they cannot be dismissed entirely. Even before it broke apart, 3I Atlas wasn't behaving like any comet we had studied. Initially detected by the Asteroid Terrestrial Impact Last Alert System, the very system from which it gets its name, the object appeared to be a typical comet, a glowing coma of dust and gas. But there was a problem. This glow was happening far beyond Jupiter's orbit, at a distance where the sun's warmth is barely felt. For ordinary comets, activity that far out is impossible. Normal comets rely on the sun's heat to sublimate ice into gas, creating the glowing halos we see. Atlas was different. It was already active, already venting material, as if powered by some hidden heat engine. Imagine stumbling across a car idling in the middle of a desert with no driver in sight. Where was this energy coming from? Theories soon emerged. Perhaps Atlas carried exotic ices, frozen nitrogen or carbon monoxide, that could sublimate at much lower temperatures than water ice. That could explain some early activity. But even this theory failed to account for the sheer scale of Atlas's outburst. Its coma stretched more than 430,000 miles across, over half the diameter of the Sun itself. It was less a comet than a ghostly behemoth threading its way through our solar system. And then, just as astronomers prepared for a dramatic close-up, it disintegrated. This wasn't a neat split into a few pieces, it was complete annihilation. A cloud of fragments replaced the once coherent body, each fragment following the original trajectory. The messenger had been silenced before it could deliver whatever secret it carried. So what caused it? Was it tidal forces from the Sun? Was it a catastrophic internal chain reaction? Or something we haven't yet imagined? Interstellar comets, having survived the brutality of deep space for millions of years, should be among the toughest wanderers in the cosmos. And yet this one came undone in spectacular fashion. The debris it left behind now follows its orbit, and here's where things get more intriguing. In 2026, Earth will cross directly through that orbit. This isn't a catastrophic collision scenario. The odds of a large fragment hitting Earth are almost nil. But the dust and tiny particles could brush against our atmosphere in vast quantities. And this isn't ordinary dust. This is material from another star system. Tiny grains moving at tens of thousands of miles per hour could carry isotopes, exotic elements, or even compounds our planet has never encountered before. It's essentially a planet-sized experiment without any controls, and no one knows what the results might be. What's more, comets are not inert snowballs. They are electrically active. As they approach the Sun, they interact with the solar wind, creating invisible plasma environments. Think of Atlas as part of a cosmic circuit, the Sun and the comet linked by magnetic field lines, with energy flowing between them. With a body as large and mysterious as Atlas, such an interaction could be unpredictable, even dangerous. And the timing is worrying. We are in the midst of a solar maximum, a cycle when the Sun is already prone to violent outbursts. Introducing Atlas's charged dust and plasma into this unstable environment could trigger massive solar flares or coronal mass ejections. If such an event were directed at Earth, the consequences could be devastating: power grid failures, satellite blackouts, communication collapses, even a modern-day repeat of the Carrington event of 1859, which set telegraph wires on fire. But beyond solar interactions, the debris itself poses another mystery. As Earth plows through this interstellar dust, it could create dazzling meteor showers, streaking our skies with trails from a star system unimaginably far away. Yet some scientists worry about less visible effects. Could alien dust interact with our upper atmosphere in unexpected chemical ways? Could it affect ozone levels? Could it even, in the most speculative but fascinating scenario, carry microscopic life forms, spreading them across planets in a process known as panspermia? Every time we think we understand Atlas, it slips away from us. Was its breakup accidental? Or intentional? Some theorists have even suggested it was designed to disintegrate, releasing fragments like seeds, spreading material across solar systems as a kind of galactic experiment. It's a wild thought, but one that underscores the central truth. We are dealing with something unlike anything we've seen before. All around the world, observatories are now racing to track Atlas's remnants, modeling trajectories, and simulating interactions with the Sun and Earth. The stakes are nothing less than planetary. Yet alongside the danger, there is awe. For in Atlas we glimpse not only risk but wonder, the vast, interconnected, and mysterious dance of the universe. So what will happen in 2026, when Earth meets Atlas's ghostly trail? Will we see nothing more than a spectacular meteor shower, a celestial gift from another star? Or will we face consequences we cannot yet predict? Each fragment, each particle of dust, carries within it a story billions of years old. A story that began around another star, countless light years away. And now, pieces of that story are brushing past Earth, whispering secrets across the void. Atlas is more than a comet. It is a reminder that the universe is alive, restless, unpredictable, and full of surprises. This is not just an astronomical curiosity. It is a cosmic story still unfolding, one that we are all witnesses to. Telescopes will continue to watch, scientists will refine their theories, and we, here on Earth, will wait, small, fragile, but endlessly curious. The saga of 3I, Atlas is far from over. In fact, it may only just be beginning.